Okay, welcome back everybody. Today is 7.3, day one. It's about word problems and using rational equations to solve them. So if I go here, it's just a reminder, you were supposed to bring a can today. I know it's so easy to forget. I'm about to send around 2 red pens. One is if you brought stuff in, you can write your name on the bottom of it and set it back there, and that way you've got yours already pre-set up for tomorrow. The rest of you, if you want to take the normal red pen, I would not do it in permanent, but a normal red pen and write a little like can, draw a little can on the back of your hand, that would be really nice. That would be a way to remember it. If you don't want that, all I ask is don't just pass this on or you're going to forget again tomorrow. If you write the can on the back of your hand, I guarantee you're not going to forget. If you pass it on, then you better do something like send yourself an email. Set your phone to go off as an alarm tonight at like 7 p.m. or something, or do something right now that will make you remember your can tomorrow. Okay, do one or the other. All right, so here we go. Hot dog eating contest. Chestnut is actually referencing in that video the guy who is like the best hot dog eating champion. His last name is Chestnut. So there you go. You know Joy Chestnut apparently. All right, cool. So Johnny Chestnut. Now, unfortunately, Ernie and Chestnut are like a first name and a last name, and so it gets me confused. I'm going to go with Johnny now that I know he's Johnny. Johnny Chestnut. Johnny can eat 70 hot dogs in 10 minutes. And both Johnny and Ernie can eat 100 hot dogs in 8 minutes. That, just to clarify, that wasn't written terribly well. Together, they eat 100 in 8 minutes. Okay? We're not talking they can separately go at this faster rate. We just have this, we're not going to make this more complicated. They are always eating at their fastest rate when they're in a competition, right? And Johnny's got his rate, which would be 70 dogs in 10 minutes. Obviously not too hard to reduce and simplify there a little bit. But both Chestnut and Ernie together, they can eat 100 hot dogs in 8 minutes. How long will it take Ernie to eat 30 hot dogs? All right, I want you to just start trying to figure out how you would set up, and I want to clarify, just one equation. You set up one equation right, and all you have to do is solve it and you get your answer. I'm going to pause for a second while you give this a shot. Sometimes these hurt a little bit because you're like, I can't figure out, try something. Don't just think. You got to try writing equations out, and I'll give you a hint. There's fractions involved. I'll pause while you give that a shot. Okay, so sorry we had a little interruption in class there, but now we're back. So the rate for Johnny Chestnut is 70 hot dogs in 10 minutes. The rate for Ernie, I don't know the rate for Ernie. That's kind of the point. So could I change this to a rate per hour for Ernie? Yeah, I could do that. I could say how many hot dogs per 1 hour, but that wouldn't really fit with the whole context of the minutes thing, would it? So maybe we should figure out how many hot dogs per 1 minute Ernie does. That could work. All right, and then I'm going to have it equal the rate for both of them. That's something I know. I know that is 100 hot dogs in 8 minutes. 100 hot dogs in 8 minutes. Okay. So now, do you get that we only have one x and therefore I can solve for it? Okay, good. Now let's actually solve for this and see what we get. Do you get this one can reduce from 70 over 10 to 7 over 1? Let's just do that because it's so much simpler. Now, do you get that this is a fraction problem where I just want to clear the fractions and multiply everything by something to make my life simpler? What should I multiply by? 8. But the x isn't on the bottom, so I don't want to multiply by the x. I just need to multiply by 8. To get this so it doesn't have fractions, I just need to multiply by 8. So I'm going to multiply this one by 8, and I multiply this one by 8, and I multiply this one by 8. Why did I do that again? So that the 8 would cancel the 8. And now I have 7 times 8, which is 56, plus 8 times x, 8x, equals 100, and the 8's canceled, so it's just 100. And now I can solve that fairly simply. 8x equals 100 minus 56. So what is it? 8x equals 44. And and therefore x equals 44/8. Would somebody take a second, use a calculator, and tell me what 44 divided by 8 is?
5.5.
All right, so that means that x is 5.5. What does that mean? 5.5 like cows in Bolivia? No, it's not that. It's 5.5 what? Minutes? Hot dogs in 1 minute. Because that's how we set it up. See, we set it up as I don't know how many in 1 minute. So if it's 5.5 in 1 minute, then could I take that 5.5 in 1 minute and then figure out how that's going to work with the 30? Absolutely. So I could take the 30 hot dogs and am I going to multiply it by 5.5? Nope. Divide it by 5.5. And I'll pause for a second while we figure that one out. And that comes out to 5.45. And that rounds to about 5.5. 5.5 what? 5.5 minutes. Because in the context of this, we're asking how long will it take to Ernie to eat 30 hot dogs? It'll take him 5.5 minutes. Okay. Now, is there another way I could have done this except even a little faster? All one equation. You can't give me away with two equations. You got to give me one equation. Yes. Yes, you. I'm going to back up, and I'm guessing it's still very similar to this, isn't it?
Well,
How about this? If yours isn't similar to this, I'm sure it's awesome, but I don't want to take too much time on this and start a whole new way. If you didn't have similar pieces, let's not try that way for right now. Who can adjust mine just a little bit and make it work? Yes. Yeah. I know that, I'm not sure you meant, okay. Okay, but how do you know it's going to be 8 minutes? Okay, that's a good try. We do need to adjust that piece, but that's not exactly how I would adjust it. What do you think? What are you saying about that then? If you put that, this is in the context of a rate, so you're saying.
so we're trying to find X is the number of minutes we're going to eat 30 hot dogs.
This is Ernie's spot, and it's 30 hot dogs in X minutes. I like it. Does that make sense to you? All right. Would you please solve that one? Which, again, I would reduce this to a 7 and a 1, and then multiply everything by 8 and X. Just to clarify, I now need to get rid of two denominators, the X and the 8. If I multiply everything by 8 and X, 8X, 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 then my denominators are all going to cancel nicely. No denominator there anymore. This was a 1, so I didn't have to worry about it anyways. And this one, this 8 cancels this 8. Now I get 8 times 7 is 56, plus this part, 30 times 8, 240. Is there an X in there? No, the X canceled. Oh, there's an X in this first one. Sorry. 56X. There we go. And that equals 100X. And please tell me when you actually solve that out that you still get the same answer of 5.5. And you might think it's more complicated, but it is an opinion question at that point. Either way was a single equation that we solved. But the nice part at the end here is we don't have to like adjust our answer and say, okay, you know how people's tendency is you solve a big problem and then you get an answer like last time we solved a big problem, we got 5.5, and then we had to actually go back and now take 30 divided by 5.5? Do you get what I'm saying? We had to do one last step. This one doesn't take one last step. So I kind of like this way too. Thank you. 5.45 repeating. All right, good. So either way, it's how long it'll take Ernie to eat these 30 hot dogs. All right, I'm going to give you another question that's like that. Not many of you know this, but Jess is a fantastic snipe hunter. How many of you actually know what snipe hunting is? Only two people know what snipe hunting is? Okay, so if you ever get invited snipe hunting, don't go, because it's a big joke on the person who's being brought snipe hunting. Up has an example of it. It's been around since the 50s. People would take their friends out snipe hunting. And because they were like, you know, like big hunters, and then they were like, you've never hunted for snipe? Oh my gosh, it's amazing. So they take people out on a snipe hunt. And the way you catch a snipe, of course, is you bring a great big bag, okay, like a big garbage bag, and you hold the garbage bag, and you'll have one person who's going to be like out like scaring up the snipe, and the other person has to stand and call the snipe and stand there with their bag, so that then when the snipe runs out, they have to just grab it with the bag. And it's all a big setup. There is no such thing as a snipe. You get the person to do, what was it again, clap 3 times, I think. They got in the movie Up, they do this. Okay, so you had to clap 3 times and like turn around and call for the snipe. And snipes like, you can make up anything you want, because they don't know what snipe hunting is, so you make up your own thing. So anyway, this person is out in the woods like going, here snipe, and like clapping and like dancing up and down, and there's no snipe, and it just like look ridiculous. And then they just get in the car and drive home and leave you in the woods. So just, if anybody invites you snipe hunting, don't go. But Jess actually is fantastic at, she actually got 3 snipe over the course of 8 hours. Yes, I'm aware of this. So 3 snipe in 8 hours. I think was it all in the calling, Jess, or was it like the camouflage, or? All right. So anyway, together, this by the way was a rate, of course. This was Jess. And Ari and Jess together, working together, they only were able to work for 5 hours, but they did get 5 snipe in 5 hours. The question becomes, what is Ari's snipe hunting rate? Are you saying because there are no such thing as snipe, you're going to go to that? No, you can't do that. That's cheating. You have to actually write a great big fraction problem. And if you know how to solve it by multiplying to clear the denominators, it really becomes very easy once you write the right equation. All right, I don't want to spend too long on this. See if you can get 2 fractions added together equaling a 3rd fraction. I'm not going to try to burn this individual, but I do see a cell phone out. I would like it to go away now. They should not be out on your desk. All right. So always set up a fraction plus another fraction equals a 3rd fraction. And the 3rd fraction always needs to be the total of the other 2. Okay? So total means them working together. So this is Ari and Jess here getting 5 snipe in 5 hours. Alone, Jess is known to do 3 snipe in 8 hours. Tapper is a big unknown. So if we want to know Tapper's rate, then we would just say, I don't know how many snipe he gets, and what could I keep simple on the bottom? In 1 hour. Now, could I have changed the problem and said, I want to know, how many snipe he gets in 9 hours? I could do that, but I think easiest right now is just to find his rate per 1 hour. And when we're done, we'll know how many snipe Ari gets. We already know that Jess gets 3 in 8 hours. Ari gets unknown amount in 1 hour. All right. Do you get that you could simplify this a little bit? Anybody have a strategy for making this simpler? Just a little bit. Yes? Yes, but there's something even simpler than that. Yes? Okay, I'm confused. Oh, you're thinking that's 5 snipe. It's not a 55 over 5, but it's still reducing that fraction, which is 1. Yes. Okay. Sorry, my writing was a little sloppy there. The 5 over 5 can be reduced to 1 over 1. Isn't that going to be a lot easier to clear the fraction then? Because that denominator all of a sudden doesn't exist. So you can reduce your fractions. You should reduce them. So now all I have to do is multiply by 8. Do you get why this one does not have to be multiplied by x everywhere? Because there's no x in the denominator in this one. So it's 8 and 8 and 8. And then this becomes, cancel, cancel, 3 plus 8x, because dividing by 1 doesn't really do anything, equals 40. Again, divided by 1 doesn't really do anything. I just got to remember the context of my question so that when I'm all done and I get the answer of like 7, I got to know what that means. Oh, is there a mistake here? Oh, I thought that, I can't even read my own writing. I thought that was a 5. It's the units. It's the s. Sorry. All right, so that's an 8. My bad. Then we're going to subtract 3 from both sides. And I have 8x equaling 5. So then x equals 5/8. So that means 5/8 of a snipe in 1 hour. So if I just times that by 10, it might be much simpler. I would get 5/8. Actually, it doesn't make it much simpler. Okay. It would be 5 snipe in 8 hours, wouldn't it? 5/8 of a snipe times 8 hours. These would cancel, and then I'd get 5 snipe. So yeah, 5 snipe in 8 hours is another way to say that. All right. So bottom line, we solved it. We got 5/8 of a snipe per hour is Ari's rate. 5 in 8 hours? What's better, 5 in 8 hours or 3 in 8 hours? Pretty clearly. You're outclassed again. All right. Yes. I know. I'm trying to be extra harsh. Oh, okay. Do you not wish to be on said recording?
No, I remember you said something about last year.
Yes. I actually try to use only first names and not last names. And so if you would, but I can easily refer to my other recording.
It's fine.
It's fine? Okay. All right. And yes, on the recordings, I sometimes won't say anything. I'll sometimes use initials, but then I was told that first names are okay because there's, but your first name is more unusual, so it's not like John, so I get how that could be. If you can tell me later if you want me to delete this video, it's very easy to do. Okay, so I want to give you one more example, and this one's about carrots.
Carrots?
Yes. I don't want to miss this opportunity because Jack is a world champion carrot puller. And not many people know that, but it's true. And he's been known to pick 38 carrots in 4 minutes. 38 carrots in 4 minutes. My question is, if we take Jack and add him to, who was bragging over here about, you think you can beat that? All right, so explain, give me an example of how many carrots you've picked in what period of time.
I can get like
40 in 4 minutes. Yeah, I'm sure you can. Okay, 40 carrots in 4 minutes. Then my question is, if I'm going to get these two jokers to come out to my carrot ranch and pick 1,000 carrots,
Wow.
how long will it take them?
Wait, was that a pun? Because carrots go well with
No, it wasn't.
Okay.
No, I do like ranch too. Did I mention that my ranch is in a hidden valley?
Oh, wow.
Okay. Anyway, so would you please try to find how long it would take them to pick 1,000 carrots? You should be able to have one unifying equation, one equation to rule them all, so to speak. All right, so did you say 38 over 4 plus 40 over 4 equals, wait a minute, I don't know what they total are going to do, except they do know something. What do I know? That there's going to be 1,000 on the top. There's going to be 1,000 carrots. The only question is how much time it will be. So there should have been an X on the bottom. Raise your hand if you set that up right. That's a good sign. Okay, I think you're getting it. So then, now that I've got this, make sure your answer makes sense in the context of the question. If you get an answer in hours or something, you probably messed something up because my question was about minutes. Now you could, of course, take your minutes and adjust it to be hours if you wanted to, but you'd hopefully be doing that fully aware of what you were doing. Okay, do you get I don't need to multiply by 4 and x? In this case, what do I want to multiply by? Just a 4 and an x. Do you get I don't need 2 4s? Oh, then I do 4s. I don't need 2 4s. I know I've always said multiply by all the denominators, but multiplying by 1 4 is going to handle both of these. See what I mean? If you had multiplied by an extra 4, it really wouldn't have hurt anything. The numbers would just be a little bigger because I multiply everything by a 4 now. Again, sure, if you want to, you can multiply by everything by 4 another time. And you can multiply by everything by 4 and again if you want to, but it's kind of a waste of time. Okay, so I'm just trying to give you some tips on saving time there. And this becomes 38x plus 40x is equal to 1,000 times 4 is 4,000, and the x is canceled, so it's just 4,000. And then I get 78x equals 4,000, and then you should add x equals 4,000 over 78, and make sure that you know, of course, that is how many missionaries live in Bolivia. Okay, fine. Costa Rica. Okay, fine. What is it? 51 point what? That is some handy carrot pulling. 51.3 minutes, and they have got a whole lot of carrots picked. Yes? Good question. Either the numbers will be easy enough that you'll be able to handle it without calculators, or you'll be provided with calculators. I'm not going to tell you a for sure answer because, to be honest, I don't know. But I do know that we would not have you doing something that's like you're not going to have to divide 4,000 divided by 78 in your head. Granted, you could do it out on paper, but that's a nasty long division problem. Okay, so we have a couple more things to learn. Not much. Look at the beginning of your homework. Everybody find this spot. That reminds me, tomorrow is a good day to get homework graded, and you can hold me to that. All right, I'm going to multiply both sides of this equation to clear my fractions. What am I going to multiply by? 5x plus 4 on both sides, and this side will cancel. And now I have x equals 3 times 5x. I'm going to actually multiply it all out. 15x plus 4 times 3 is 12. You should be able to solve that. You just subtract 15x from both sides, or subtract x from both sides, and then subtract the 12, and then divide by, you can handle it. Should be easy from there. Okay, how about over here? This one's going to have a quadratic when we're done. All you got to do is multiply both sides by x squared plus 1. But the catch is that now you have a quadratic. I want to just take this moment to remind you, 1 times that, of course, becomes just that, that a quadratic needs to be set equal to 0 first. Then, if you can factor it, say it. You should. And then, if you can't factor, what? Quadratic formula. Very good. Much weaker answer on that because some of you didn't know. If you can't factor it, you should use quadratic formula to solve it. Okay? I think this one will probably factor, but if it doesn't, quadratic formula can solve all of them. Then what if we were talking about carrot picking and the answer came out to like -3? I'd be really careful to make sure that you aren't thinking that somebody is actually putting carrots in the ground instead of picking them. You know what I mean? Just be careful with your negatives that you don't have imaginary or like extraneous answers. All right, this one does not have context, and therefore we can solve it and get negatives, and that's okay. All right. Now, I know when we hit this screen, a lot of you are going to say, well, I'm going to multiply by x plus 2 on both sides. But you can't. Let me explain why. Because when you have a greater than or a less than, do you remember the rule that if you multiply by a number on both sides, wait a minute, if you multiply by a negative number on both sides, the sign has to switch? What if you multiply by x on both sides? How do you know if you just multiplied by a negative or a positive number? You don't, and so then you can't. You cannot multiply both sides of an inequality or divide both sides of an inequality by an x. So I can't start by multiplying by x plus 2 on both sides. I can't. It's not allowed. Okay, because I don't know whether to switch the sign or not, or maybe it's kind of both. Okay, so you don't do that. Instead, let's look at what it says we should do. Hint, draw a number line. Okay, so there's already drew a number line right here. Next, identify the x values for your vertical asymptotes and your x-intercepts. Remember vertical asymptotes? Those are those things that are on the bottom, right? Okay. Your x-intercepts are where y equals 0. This is like a y, and if y equals 0, the x-intercept is what makes that equal 0. This is a little bit of a weird one. If you have 1 divided by something, can you make it equal 0? No, you can't. So this does not have any zeros. It does have something that'll crash it. -2 will crash it. That's why they put -2 on the number line. But normally, you are looking for the, stop with the noise, please. We're looking for the x values as in the vertical asymptotes and the x-intercepts. Okay? The x-intercepts are different than the vertical asymptotes, but the vertical asymptote here is at -2. So moral of the story, you set this and you say -2 won't work. And here's the cool thing. Then either everything to the right of it works or everything to the left of it works. Remember, these are ranges of answers. Like your answers are like A is greater than 6. It's like a zillion answers that are bigger than 6. So the answers aren't just like a number. The answers are a range of numbers. So the answer is either everything works this way or nothing works that way and everything works that way. Or sometimes you test both sides and both sides work, and the only thing that doesn't work is like -2. Okay, but you have to test on both sides of that important point. All right, so let's do that. What's something bigger than -2? Pick anything bigger than -2. I heard 1, 3, and 0. I'm going to pick 0. Okay, if I pick 0 and I put in a 0 right here, I stick in a 0 into my original, am I left with a true statement? Is 1/2 greater than 0? Yes, it is. Okay, so that worked. And you assumed from, I have that happen all the time. People assume from the way I say stuff that I'm going to make your answer this way or that way, but nope, this one, this is not a problem. 0 going in works. Okay, how about if I put in like -3? Check. Use your brain before you talk. 1 divided by a -1. That makes -1. Is -1 bigger than 0? No. All right, good. So final answer, -2 is not going to work, but everything bigger than that does. So you could write that in interval notation like this, -2 to infinity, where it can't be this and it can't be that. Or you could have left it as a number line, because a number line is one of the 3 forms that we say is an okay way to write a set of answers. Okay, so next one, let's do this again. Do you get that on this one, things that would crash it would be -2. I'm purposely not answering your question right now because we're running out of time. I want to get to this. -2 is important. And then the other one that's important is that was the vertical asymptote. The other one that's important is the x-intercepts. The x-intercepts are where y is 0. Okay? So where is this equal to 0? When is that equal to 0? When the top is 0. Do you get if the top was 0? Doesn't matter what the bottom is. 0 divided by any other number is going to be 0. Okay, so my x-intercepts are y is 0. How do I make this equal 0? If it's 3. So +3 is the other important thing. Okay, so those two are important. Now my question is, one of them doesn't ever work. Which one doesn't ever work? -2. So this is a spot where it's a U. It's called undefined. And 3 is a 0 because it makes the equation equal 0. Is 0 a bad thing in this case? Because 0 is equal to 0, so that would not be a bad thing. It would actually work there then. But now we have to test our intervals. Put in a number like 4 and see if it works. Is 4 minus 3 over 4 plus 2, is that less than 0? 4 minus 3 is 1. 1 divided by 6, 1/6, is that less than 0? No. Doesn't work. Cross it off. Now how about something between -2 and 3? What's my favorite thing to test on there? 0. I'm going to put in a 0 and see if it works. 0 and 0, and I get negative 3 over positive 2. That's a negative number. Are negative numbers less than 0? So it worked. Yay. And now we test the zone in here. What's like good in here? Negative 3 maybe. So negative 3 minus 3 is a negative. Negative 3 plus 2 is a negative. A negative divided by a negative makes a positive. Is any positive number, I don't even care what it is. If a positive number, is it going to be less than 0? No. Positive numbers are not less than 0. So I'm crossing it off. And there we go. From negative 2 to 3. All right. Then don't forget what we started this hour. It was all about this person's rate and that person's rate making a total. Okay? Well, they've twisted that a little bit on this problem for you, but it's similar. And this last one is a classic about two swallows working together to carry a coconut. One swallow alone might not be able to carry the coconut because their swallow, their weight ratio, etc. But together, two swallows might be able to carry a coconut together if they lashed it to their feet and it just gets completely ridiculous. This movie clip is well worth it, though. I'm going to show you this Monty Python clip. Can't argue with their logic. That's all I have for the video for today. Oh, by the way, your homework, I am having you just do up to that problem, up to number 22 for today.